Good morning, good afternoon, good evening, good night, whatever. Welcome to the Unit 2 of the Module 1, which is titled Basic Set Operation. On here, we will be discussing the language we use in sets, as we have under numbers, basic operation like addition, subtraction, multiplication, which we call arithmetic. Here we're talking of the language in sets, which are fundamental to set operations. So we'll be talking of the union of sets, intersection of sets, and the likes. Let's go. At the end of this lesson, you should be able to compare two sets and assign that set based on comparability, and also represent relationship between sets using Venn diagram. So what are set operations? In arithmetic, in numbers we talk of addition, subtraction, multiplication, but in sets we talk of union, which can be likened to addition. We have intersection, differences which are likened to subtraction. We have complement and the likes. So let's begin. Union of sets. What do we mean by union of sets? When I'm talking of union of sets, we are talking of the sets, the combination of two sets or more. You can have union of two or three more sets, two or more sets. So a union of set A and B is the set that contains all elements in set A and all elements in set B. So the combination of the elements in the two sets match together is a union of that two sets or three sets. So let's see this example. We have set A, which have its element to be A, B, C, and D, while set B has its element to be C, D, E, and F. So the union of two sets is A union B will be A, B, C, D, E, F. You don't have to repeat that C, D since you have C, D in both of them. But the union of set A and B. Now, look at the diagram here. It shows the union of set. So it contains every element in set A and in set B. Also, we have the properties of union. Of course, if we have A union A, the same set, so that means the union of their union will be A. And A union nothing, that is A union empty set, will give you A. And if you have set A, which is a subset of set B, then A union B will be B, since all elements in set A are contained in B. So A union B will be in B. So let's talk about the next one, which is intersection of sets. Intersection of sets is talking about the element that is common to both elements, both sets rather. You have set A and you have set B. The element in set A that is also in set B is the intersection of the two sets. Take for example, we have set A 1, 2, 3 and set B 2, 3, 4. So we have 2, 3 in set A, 2, 3 is also in set B. So 2 and 3 are common to both set A and B. So intersection of set A and set B is what? 2 and 3. So the Venn diagram shows the intersection, that is the element that is in either A and also in B. So the properties, if you have intersection of A and itself, that will give you A. And intersection of A and empty set, there is nothing that will be common between empty set and A, that is empty set. And if A is a subset of B, then intersection B will be what? Will be A. Remember, for the union, A union B will be what? Will be B. The intersection. So that is the only that is common, only the element that will be common to A and B. Let's go to difference of sets. Difference of two sets. So difference of two sets A and B, that is A minus B, is that set X, so that we have the elements that are in A but not in B. the element that are in A but not in B. That is basically what the difference is. Take for example, you have set A 1, 2, 3, 4 and set B 3, 4, 5. What are the elements A that are in B but not in B? You have 3, 4, 5 in B, 3, 4 are in B and also in B. So all those elements that are here that are not in B are 1, 2. Those are the difference of set A and B. We also have symmetric difference. The symmetric difference means that you first get A minus B and get B minus A, then the union of the two. That is the symmetric difference of A and B. So that is elements in A or B but not in both. Let's talk about the disjoint set. A disjoint set is set that you have two sets. Two sets are said to be disjoint if they have no element in common. Set A, take for example, set A is 1, 2, 3 and set B is 4, 5, 6. There is no element that is in A that is also in B. None. That means they are disjoint sets. So complement of a set. Complement of a set are elements that are in that general set but not in the set under consideration. That is, if you are talking of set A, any element that is in the general set but not in set A is called complement of set A. Take for example the set, if we are considering students in National Open University of Nigeria, that's our general set, and we say our set A is a set of students ordering MTH 106. So the complement of set A is every other student in National Open University of Nigeria except those people ordering MTH 106. So we have the properties of the complement of set. A union A complement is a universal set. That is the addition of set A and its complement. That will be universal set. A intersection A complement will be empty set. That is, it cannot have anything in common. So followed by we have our De Morgan's law. What are De Morgan's law? If you have A union B in bracket complement, we give you A complement intersection B complement, and you have A intersection B complement, give you A complement union B complement. We have seen what a linear intersection difference and complement of sets are, and we liken them to the arithmetic operation in numbers. Thank you for your time, and I urge you to practice the self-assessment exercise in that unit too. Have a nice day or nice night. Thank you. We'll see you next class.